This module is about printf and scanf. My purpose here is to show you some of the many things that printf and scanf can do. We haven't seen, by a long shot, the various options that are available to us. I've prepared a source file here called printf.c. You'll find it in the Chapter 3 folder of your CD. This is a demonstration of the use of printf. I'll run through some various different data types. I'll look at integers, I'll look at doubles, I'll look at strings, and as a subset of strings I'll actually even talk about individual character formatting. I'll show you the various ways that these values that we have here, 415, 3.14, len is special, I won't talk about that just for the moment, and the string hello, I'll show you the various ways that those can be printed out to the screen using printf. I'll start with strings. So let's scroll down a bit. Okay, I'm printing out this string here. It's simply 30 digits. I just want them printed on the screen as a reference, such that when you see the output that's created here, you'll be able to reference it against something. Firstly, I'll just print out the string itself, followed by 4 little arrows just to show you where the string finishes. Obviously where the first arrow is, that's the end of the string. The reason why I've put those arrows in will become obvious in a moment. Anyway, let's get into it. Let's see what it does. Compile the project and run, and we get our 30 digits across the screen and a hello, and then that's the end of the string. Okay, that's fine. Don't worry about all this, I'm going to get to that. Okay, so let's scroll down a bit. What else have we got? We have got a %10s. Different now from %s, we've got %10s. Putting a number there says I want the string displayed in a minimum of that number of characters. So I want a minimum of 10 characters of output here. So let's see what that looks like. I'll run it again. A minimum of 10 characters of output. So we've got 5 spaces and then 5 letters, and that is in fact the 10, as you can see right there. The string is right justified. That's quite important. You'll have to remember that. It's right justified. We've got a -10s, which makes it left justified. And we'll have a look at that again. And there it is. Left justified, 5 spaces after it now. Now we have a 0.3s. Instead of 10s, it's now 3s, but it's actually 0.3s. And if the number is after a decimal place, that represents the maximum number of characters that can be output. This is, if you like, the minimum number of characters. This is the maximum number of characters. Let's have a look at that. And yes, we've got a maximum of 3 characters being output. Finally, and this is quite a special one, if you don't understand it, don't worry, it's somewhat advanced. See where I've got the 3 there? I've replaced the 3 with an asterisk. An asterisk means get the number of characters it's required to be from an integer parameter. So that the value of len, which if you look further back up here is 7, len is 7, so what this is saying is display a maximum of 7 characters. A maximum of 7 characters. Let's have a look at that again. Well, there's only 5 anyway, so it only needs to display 5. Those are most of the important options to you available when printing out strings. Now let's look at printing out other things. I'll scroll down a bit. Integer formatting options. Again, we've got a reference line, %d. Now what was our number again? 415, I think, from memory. So let's see what that looks like. Run the project. 415, just printed out by itself. Okay. Again, printed out in a field width of 10. In other words, print it out such that there is a minimum of 10 characters, and pad it with spaces if you need to. Let's have a look at that again. And sure enough, there's 10 spaces just there, just before the 415, and you can see that that's exactly 10. Next, 010d. 010d. That means print it out in a field width of 10, in other words a minimum of 10 characters, and instead of padding it with spaces, pad it with zeros. So let's have a look at that. And there it is again, almost exactly the same. Instead of spaces there, we've got 7 zeros. Now again, this is very similar. Len is set to 7, I think you'll recall. So this is, if you like, equivalent to %7d. This is just like what we saw earlier with strings. %7d, so it should come out in a field width of 7. And there it is, in a field width of 7. Not quite as long as these guys, padded with spaces. %-10d, again, make it left justified rather than right justified. Let's have a look at that. And there it is, with the 7 spaces afterwards, right there. And finally, 0.1d. Now remember from the strings that 0.3 means a maximum of 3 characters. So what we're saying here is I want a maximum of 1 character. Let's have a look at what happens. It might not be what you expect. You get 415. So what's this about a maximum of 1 character? Well, I think it's quite important in numerical output that the actual number is displayed. If you only want to print 1 digit, which digit are you going to print? The 4 as in 400 or the 5 as in 415? Printf has made a decision that if a number is going to be printed, the entire number is going to be printed, if it's an integer anyway. So you cannot actually specify a minimum that's smaller than the number itself. So this little 0.1 here has no effect. Sorry, that was a maximum, not a minimum. Moving right along, we'll have a look at the printing of an individual character. Now we need an individual character. If you recall, up high, there is no individual character. I haven't got any char types. All I've got is this, which is a string. Well, it's 30 chars, so surely I must be able to use one of the chars in there, and I can. So I'll scroll back down again, character formatting options, there's our reference line again. %C this time. %C, you haven't seen that one before. Print out 1 character. Which character? Can you guess what that is? Can you guess what I'm looking at there? String bracket 0 bracket. What is that? Well, if you recall, it's actually the first character in the string. Remember that arrays always start with 0, they never start with 1. So 0 is the first element of the array. So we're going to print out the first letter in string. Now what is string again? Let's go back up and have a look. It's hello. Okay, so probably we're going to be printing out an H. Let's see if that works. An H, there it is, just by itself, 1 character. And here, it's all the same really, it's just the same stuff as before. Print out 1 character in a field width of 10, and you can see what that's going to look like. There it is, 9 padded spaces up there, and then the H right justified. If you want to left justify it, again use -10C, and so on. Moving right along to floating point operations. Now here you can actually specify how many decimal places you want to see, and you can also specify how wide the number is going to be. %F, let's just see what printing out a float looks like. Actually, in this case we're printing out a double, so when you see an F it's actually referring to a double. F is the new thing that you haven't seen before, %F. Let's have a look at that. 3.141590. Okay, so we're getting 6 decimal places and a point, and so that's worth noting. %10F, printed out in a field width of 10, so pad it with spaces if you need to. Again, so we just get a couple of extra spaces at the beginning. Now, %10.3F. We're specifying, now this is not a minimum and a maximum this time, it's a field width, in other words a minimum field width, and then a number of decimal places. Let's see what happens there. Run the project. So we've got a field width of 10 and 3 decimal places. Okay, so that's working. Finally, 10.8F. What happens if you specify more decimal places than you have in the number? Let's see what happens. Run the project. It actually pads it with zeros at the end. Okay, which is probably what you expected. Finally, there's one little thing that you should know about, and that's %%. I mean, what happens if you actually want to have a % come out in your printf string? Well, %% just gives you a percentage sign. So if you ever need to get a % sign formatted out through printf, you use %% to get it out. Okay, now I haven't covered absolutely everything that printf has to offer, but I've covered the stuff that you're going to be using probably 98% of your programming life. There are a few more. You can print things out in hexadecimal or octal representations. You can print out unsigned versus signed numbers. You can print out representations of pointers, but these are rather obscure and not used very often, so I'm not going to cover them at this point. Next we'll have a look at scanf. Now I have on the screen scanf.c, which will be used to demonstrate how scanf reads input from the keyboard. I won't begin going into quite so much detail with scanf, mostly because scanf is actually not used all that commonly to read data input. It might look like it is, but it isn't. You might think, well, what is used more than this? Well, that's a funny question to answer. If this is the sort of thing you need to do, scanf is the only thing that really does it for you. What I'm really suggesting is this isn't the sort of thing that people do very often. So anyway, to move on. Now we have X and Y again, but they're not set to anything because we're going to read them in from the keyboard, and again a string. Notice that the string is 100 characters long, which means I have room for 99 characters. The user can enter 99 characters, or possibly 98 if you include the new line character that they're going to enter as well. It depends. So let's have a look at some string input. Here we have entering one word. Please enter one word and read that word. Now, I don't know if you know this already, you may have been practicing this in your own time, but %s will only read for you one word. If you type in your full name, Mark Virtue, or something like that, it will only read Mark and store Mark in the string. It will not store Mark Virtue. Now that's a bit odd, but that's the way scanf is defined. It will read up to, but not including, the first white space, such as a space or a tab, or even a new line character, and it will not read that space or tab or new line character. And it will store that word in string for you. Now, if you actually want to read an entire line of text, like if you say to somebody, please enter your name, and you want their full name with spaces and everything, then the way to do it is a little bit more complex. Look at that right there. Instead of %s, I've got %bracket, caret, backslash, n, bracket. Ew, what's going on there? Well, let's see. The backslash n just means new line. So what I'm trying to say is read up to a new line, but not including the new line. It won't actually read the new line in, but it will read everything up to the new line. So I put brackets around that, and a caret. The caret sign means not. Well, it means not as far as scanf is concerned, anyway. So, how that actually reads is, read in any number of characters until you get to a new line. So in other words, read in characters that are not new lines. The caret means not. So not new lines. I know it looks a little bit complex, and it is, I suppose, a little bit complex, but it's the only way to do it with scanf. And then it says the text you entered was, and so on, and prints it out. Let's see if that works. It may not. Compile. Compile's okay. Run. Enter one word. Mark. Whoa, hey, hang on, this has not done what I expected. Enter many words, and it's not stopped to wait for my many words, it's just entered Mark. Okay, so what's actually happened here is that scanf, I'll just close that window, scanf has read up here, it's read Mark successfully into string, but the next thing I typed after MARK was a carriage return. That carriage return did not get read by scanf. It was sitting there unread when we got to this scanf. And this scanf says, well, read everything in up to and including, but not including a new line. So it says, alright, there's the new line, time to stop reading. So it actually, in fact, reads nothing from the keyboard and then stops, which is exactly the behavior that we got. So it's quite easy to fix, and you've seen the fix before. We do an F flush of stood in. Stood in case you're wondering, is standard input. Standard input. And standard input is usually the keyboard. So flush anything from the keyboard that has not yet been read. Let's try that again. Okay, and run the project, enter one word, Mark, okay, this looks a bit better. Mark, I can't even spell my own name. Mark Virtue. The text you entered was Mark Virtue. Okay, so that's looking like it's behaving itself. Let's move on and look at integers. Integer input is something that you've seen before. Please enter a number, %d, remember the ampersand, very important, absolutely important. And also recall that we didn't use the ampersand with strings. And there's a very special reason for that, which we are not going to go into right now because it involves pointers and memory addresses and it's a little bit too confusing at this point. Strings are the only things that you don't use the ampersand for. You use ampersands for everything else. And then the number you entered was, let's check if that works, compile, OK, run, please enter a number, 234, and that works. OK, so that's all behaving itself too. Let's move on. OK, now we're going to have a look at character input. Please enter a single character. And there of course is the %c, just like in a printf. Now, we need a place to store it. This is going to be perhaps a little confusing. We still need the ampersand because we're not reading in a string. I know it looks like we are, but we're not. We're only reading in a single character. And the only time you don't use ampersands is when you're reading in strings. When you read in a single character, you most certainly need an ampersand just along with everything else. Now, where are we going to put that character? Well, we're going to put it here, like that. String 0. Recall that string is an array of characters, while string 0 is a single character. So we're actually going to take our character and insert it into the very first element of the array. That's where we're going to put it. And that's not a bad place to put it. We could have declared a variable, which is a single character, to store it, and that would have worked as well. It would have worked fine. And when we print it out, we print it out from exactly the same place. String 0 is a single character. The quotes that I'm putting here, the single quotes, are my own idea. They're not necessary. They're just for decoration. Now, I'm pretty sure most of you will understand that. Scanf is actually capable of reading in multiple characters at a time, but it has to read them into an array of characters. Now, I want to draw a strong differentiation here between an array of characters and a string. An array of characters is simply that, an array of characters. A string is an array of characters with a null terminating character on the end. Now, you can do things with strings that you can't do as simply with arrays of characters. Like you can use strcpy and strlen and printf and so on and so on. You can do those things with strings. They don't work with arrays of characters because not having a null terminating character on the end screws everything up. Okay, so having said that, if you want to enter multiple characters using scanf, you have to enter them into a string. Now this is going to look awfully confusing to you because most of you will have no understanding of the memory map of a particular computer. But I'm going to read 4 characters, probably that much is clear. And again, this line of code is exactly the same as this line of code. I'm reading them into string 0. Well, I can't read them all into string 0, even though that looks like what I'm doing. What's going to happen is the first one's going to get put in string 0, the second one's going to get put in string 1, the third one's going to get put in string 2, and the fourth one's going to get put in string 3. How is that going to happen just magically and automatically? Well, if you understood memory, you would probably understand why that's happening, but I'm not going to explain that to you until we get up to the pointers chapter. So just for the moment, I think you're going to have to memorize this as a bit of C magic, or at least scanf magic, and follow this lead. If you want to read in multiple characters at a time, you have to read them into an array of characters. Now, it will put 4 characters into that array, and it will not put a null terminating character on the end. It will not do that. It will read 4 characters and that's all. The 5th character will be random. It could be anything. Who knows? Scanf will not put that null terminating character there for you. So it is only valid for you to read those 4 characters out again one at a time. You can't treat them collectively as a string. You could, if you wanted to, manually put a null terminating character in the 5th spot in string 4, and then you could treat the whole thing as a string. But we're not going to do that. So we're simply going to read in 4 characters into the first 4 positions of this array. It's not going to be a string, even though this is the word string. I know that's confusing. It's not going to be a string. It's only going to be 4 characters in an array. and then we're going to print them back out again. %C, 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 1, 2, 0, 1, 2, 3. Okay, let's see if that works. Compile. Okay, run. Please enter a single character. M. The character that you entered was M. Good, that bit's working. Please enter 4 characters. 1, 2, 3, 4. The characters you entered were 1, 2, 3, 4. Okay, so that's working too. Great, let's move on. Finally, we'll look at how to read in a decimal number, a floating point number, from the keyboard. It's almost exactly the same as reading in an integer. There's only one thing that you've got to watch out for. F here, when we use printf, we're printing out a double or a float. When you're reading in using %f, it's only a float. The variable that you're reading into must be a float, not a double. When you use %f to print out again, it can be a float or a double. Okay, so that's a little rule that you've got to keep track of. Yeah, it's pretty straightforward. It's almost exactly the same as the integer. So let's have a look at that. Compile. Okay, and run. Please enter a decimal number, 1.2. The number you entered was 1.200000. Well, we could get rid of all those zeros. We know how to get rid of all those zeros if we want to. There are 5 of them. We could change the output as follows. We could say %.1. We only want 1 decimal place. And let's try that. Okay, run. 1.2, 1.2. Mind you, if we'd entered 1.23456, we'd still get 1.2. We don't necessarily want that restriction. So I'll take that back out again. Okay, so that's floating point numbers. And that concludes the module on printf and scanf.